Can you believe we finally made it to June? Remember March, back when we used to go to school? Seems like so long ago. So, this isn't really the way I had hoped to say goodbye to you at the end of the year, but this is what we got. So this will probably be the last time you see me or hear from me, at least in this format this year. And I'm hoping we'll see each other again in the fall. We just don't know what school's going to look like. We just have to wait and see. So today is the last lesson of the year. Next week, I will have a quiz for you, and this will just be to wrap up this short little look at probability that we've taken over the last couple of weeks, and that'll be that. And so I do want to remind you the way grades are going to be done this year. I know it's been confusing because we came up with a plan, and then the state said, yeah, you have to do this plan instead. So bottom line, third quarter grades don't really matter. I mean, they're interesting, but they don't count for your transcript. But what's going to matter in your transcript is your second semester grade. So it's going to be very simple. You get one of three grades. You'll either get one of two grades, actually. The higher of your current grade or the grade that you left on March 16th with. So you either get that grade, the higher of the two, or you'll get an incomplete. I know some of you have, for various reasons, just not been able to keep up during this time that we've been home, and that's part of reality. So for those of you in that particular boat, what will happen is your grades are basically frozen until fall. They're not posted. They're frozen as an incomplete. And then in fall, when we start having our half days, this is the bad part of it. When you have half days and the rest of the school goes home, you will get to hang out and do your geometry to make up the part that you missed this spring. So that's that. You will get something on your report card. It'll either be a grade, again, the higher of the two, or you'll get an incomplete, which is no harm done. You just get to come back in the fall and finish that up. Okay. Also, I wanted to mention that at some point in the next few weeks, I'm going to have to get your books back. I don't know exactly how we're going to do that yet. We're going to have to wait and see if we move into a different phase for reopening that would allow us to actually be together and have you turn your books in at school. I don't know what it's going to look like yet, but keep your books handy because I will collect them back this spring for sure, and then we'll have them in place for the next group to come through. Finally, if you're wondering about your schedules for next year, because by this point we probably would have usually had them done, I don't have a good answer for you. Other than, I think what's going to happen is that all of the classes that are easy to schedule, like, you're going to take an English class and maybe you have a couple choices on that, but you're going to take a math class and I kind of know where you're all going to be based on that. Those sorts of classes you can be just placed into. And then when you're going to have a decision to make about maybe some electives, that's where you'll probably hear something from Mrs. Dennis, and she'll either send out a form for you to fill out or some sort of survey that says, here's where I'd like to take these periods, and we'll get you a schedule. And I guess my best bit of advice is don't panic if school ends, you don't have a schedule yet. We'll make sure everybody has a schedule by fall. But again, we don't know what fall is going to look like. And that's a little bit intimidating and scary, I know. But we're not going to worry about that now. We're going to focus on what we do have. And what we do have is probability. So the type of probability I want to show you has a special name. It's called conditional probability. And it can be a little bit confusing. I'm going to try to introduce it to you in a way that makes it less confusing. But it can get really confusing. And before we're done today, there's going to be a pretty gnarly looking formula, but I'm just going to walk you through it, and I think you'll be able to handle it just fine. So if you remember, probability is simply a ratio, right? It's a fraction that compares the number of outcomes we consider a success, like what we're looking for, to the total number of outcomes, numerator to denominator. All conditional probability does, this is not a mathematical thing, this is me just talking to you, is changes the denominator. So I want to show you a problem here. And the catch here is that this is a table of data, and I want you to copy this down. So talk through it just for a second, then I'm going to let you pause the video and finish copying this down, and then we'll restart it again. This is a survey of a whole bunch of people. I've got 150 people total here, males and females, and they were asked, which is your favorite sport of these three to watch on television? Football, basketball, or baseball? And you can see how many answered in each one. And notice that the bottom row is the total. It's not a third category. It's not males, females, and then a third category. It's just a total of how many people like football, how many people like basketball, and so on. So I'm going to give you a second to pause the video, and you can copy these down on your own paper. And then I'll actually turn these and put these onto the whiteboard as well. Okay, let me move over to the whiteboard and set up this table so that we can see what it looks like. So we have males, females, and total here. And we have football, basketball, and baseball. The numbers were 40 and 12 for a total of 52. Basketball were 22, 16 for a total of 38, and 15, 45, total of 16. So a couple of things jump out to me. First of all, and this is not a really mathematical statement here, but it looks like among those who like football, a lot of them are male. See that? 40 versus 12. But among basketball fans, it's kind of split pretty evenly. I mean, yeah, there's a few more males, but generally split pretty evenly. But then among baseball, curiously enough, the females tend to be a little bit higher. So there's sort of, so this story you can tell about the values, about the numbers, even before we start doing any sort of mathematical calculation. Well, speaking of mathematical calculations, what if I asked you to find the probability out of all these people that anyone loves baseball? What's the probability that baseball is the favorite sport? And those of you with a little bit of experience working with probability will recognize that I just have to figure out on top here, who are the people that like baseball? And then down below here, how many people total do we have? And that shouldn't be too difficult, because I think you might recall I said we had 150 people, and then clearly 60 of them like baseball. So 60 over 150 becomes 6 over 15, becomes 2 over 5, which we can write as 0.4 or 40%. Okay, I'm going to use all those different, I'll use each of these different notations here in just a minute, because we're going to do a little comparison. But I want to, before we do that, I want to take a look at a different question here. And that is, what about just among women? Like we're only interested in women here. What if I put a condition on this problem, and that condition is that I'm only looking at women? It would look like this. It's the probability that somebody likes baseball prefers baseball, given that the person is female. Okay, so this bar right here, this bar right there, is the condition. And we read that bar as the words given that. Don't think absolute value, don't think anything funky. It's just a symbol that means I want the same kind of problem here, but I'm only talking about a smaller group of people, not all 150. Remember what I said on the previous screen? Conditional probability changes the denominator. So this condition here of female means I'm changing my denominator. How many females do we have in this problem? Well, there's 12 there. Now I know those 12 don't like baseball, but we're just talking about all females here. So there's 12 females there, 16 there. If I add those up, I get 28. And if I add these 45, I get a grand total of 73. So what I've done by putting this condition on the problem is I've changed the denominator from 150 to 73. And now I'm interested in, of those 73 people, how many of them, those women, prefer baseball? And that should be pretty easily found right here, right? So I can just write 43 here, 45 I mean, and there's my answer. And there's no way to reduce this easily because 73 is a prime number, but I've got a calculation here, and this is about 61.6%. So we can say here is overall, there's about a 40% likelihood that a person chosen at random likes baseball, prefers baseball. We can say that 40% of all the people prefer baseball. But among the women now, a larger percentage prefer baseball, 61.6%. And to be clear, remember at the very beginning, let me just mention this real quick. At the very beginning, I told you that among the baseball fans, there was a majority of women. That's a different condition because that condition is setting 60 as your denominator, and we're taking 45 out of 60. We're looking at women, given that it's baseball, it would be written like this: probability of female given baseball. And that is 45, 60. So I hope you can see here, there's some real different ways of talking about statistics and probability. And that's where, first of all, people get really confused, but it's also where bad people can tell you lies and convince you of them. So here's something that's interesting. The baseball probability was 40%. But when we attached the female condition to it, that is, knowing something about the gender of the people we're talking about, that changed the probability, didn't it? And that takes us back to the concept of independence. Knowing something about the female changed the probability. So preferring baseball and being female, we would say is not independent. They are dependent on each other. What do you think? Well, let's look at this formula. I told you there was going to be a pretty gnarly formula coming, and it looks a little bit daunting. I'm going to pull it up on the screen here, on the other screen, so you can see it, and then we'll just talk about it. Okay? Ooh, did not want to blow it up that far. Okay. Let me go back to this now. Okay. See this? Yeah, right. What's it saying? Well, see that bar on the left-hand side there? A bar B, that is a probability of A, given that B has already occurred. Remember that phrase I told you, that vertical bar means given. And that probability is defined in terms of other probabilities. That's a little bit different than what I just showed you, but I'm going to show you how it comes out to be the same. So the denominator is the probability of the condition. In this case, it would be the female part. Remember, think about this 45 out of 73 number. We'll come back to that in a second. So this changes the denominator, and the top is now the probability that both of these things happen. It's the count of who's in both categories, but it's done in terms of probability. So that's the formula. I'm going to give you a second. You might want to pause and copy that formula down. And then when you're done, press play again. We'll pick up right where I left off. Okay, so I hope you have that down now. We're going to go back to the whiteboard. Let's see what we can do about this. You should have your data handy. I will pull it back up so we can refer back to it if we need to. There it is. So we got this right here. I'm going to change this and put it in the context of baseball and females, not just A and B. So the probability of baseball, and this was our first problem, given female, remember this is A and this is B, was the probability that someone likes baseball and was female. We'll talk that through in just a second. Divided by the probability that they are female. Remember, this is B, this is A and B. Okay? And just for reference, we're thinking this answer is 45 over 73. And I told you how we're changing the denominator. That is my way of thinking about it. That's not the formal mathematical way, but I think you'll see where this comes from. Okay, so let's figure out what this is. Let me switch back. And we want to find the probability, hang on a sec. We want to find this probability here of a person being female, okay? So as I go here, I should see that females make up 73 of the 150 people. Those numbers should be familiar to you. So what I'm going to say here is the probability of being female is 73 over 150. That's just my denominator. And then for the numerator here, sorry, it's really sloppy, but it's the probability now that a person prefers baseball and is also female. So I'm looking at not just baseball, which is this vertical third column, but also females here. And the only number in this whole chart that's in both baseball and females is the number 45. So out of the grand total of 150 people, 45 of them are females who like baseball. I say that fast so you don't think I'm pausing or setting anything up. So now what I do is I write 45 over 150. Now, real quick, look at this. This is a nice clean expression, isn't it? This is not quite so clean. But I bet if you think back, you just might remember how we divide fractions. Remember something like multiplying by the reciprocal? So I take 45 over 150. Instead of dividing by that fraction, I'm going to multiply by the reciprocal of this right here, which is 150 over 73. Oh, you see what's about to happen? 150s cancel. And our answer is 45 over 73. It's a thing of beauty, isn't it? It seems like magic, but it's real and it's spectacular. So we're going to play around a little bit this week with this idea of conditional probability, taking charts and tables and counting and changing our denominators and so on. You have this formula, which is not on my screen right now. Maybe let me write the formula. Probability of A given B is the probability of, and I'm going to use a little bit simpler notation here. A and B. Okay, so this is your formula for the week, for the day. Just make sure that you are very clear when you articulate which event is event A, which event is event B. Okay, this is it. This is your last assignment of the year, guys. I'll have a quiz next week, and then that'll be that. I'll see you again in fall of 2020. Assignment 1 option from your book, page 511. Last time you got to use this book, maybe 14 to 21. Number 2, I do have I'm going to call this conditional 1 and conditional 2 because they don't have a better way to label them. This is going to be page, that's a weird way to write the word page. Page 1 only. This will also be page 1. So it's about the same number of problems. I'm not trying to keep track of which one is more or less, but one of those assignments, please get those into me by the end of the week. Quiz next week will cover basics of probability, of mutually exclusive, of independence, and conditional. Nice and easy. Everybody goes out on a high note. And then we get a real summer, which is going to feel a whole lot like the way this spring has been, except a little bit hotter. So I miss you guys. Be well, be good, be nice to your parents, if it's at all possible. And I really, really hope I get to see you again in the fall.